Hey folks, how's it going? Welcome back to another amazing week of math. I'm really excited to be bringing you some great stuff this week, and I'm really looking forward to another good week. So here's my problem for you today, and this is for Monday, May 4th. And as I say, may the 4th be with you. So, Luke is flying along the Death Star. C-3PO and Han are located at 2 points along the Death Star, which you can see here. They are 3 kilometers apart from one another. If the angle made between Han and C-3PO is pi over 4 radians, find the circumference of the Death Star. You can see we have the angle between them as pi over 4 radians, and we have these here, and these are 3 kilometers apart. Now, remember from last week, we talked about these so-called inscribed angles, which you can see here. And an inscribed angle is any angle formed where you take a point on the circle and you connect it via what we call chords to 2 other points on the circle. Okay, so if we take the points, if we take any 2 points, we keep them fixed, and we move the vertex around the circle, like you can see here, of the angle. No matter what point we choose, this angle is going to be half the measurement of the central angle. And the central angle is the angle formed by the center, like central, and those 2 points. So this angle always stays fixed, and this angle is going to be moving. But no matter what point we choose, and this is really important, it's going to have the same angle measure every time, and it's always going to be half the central angle. Okay, so knowing that, okay, and remembering that the total measurement in radians of a circle is 2 pi radians, which is equal to 360 degrees. Go ahead, pause, try to solve this, and when you're ready, unpause, and I'll show you what I got. All right, here we go. Very excited. So what we have here is we have this is an inscribed angle. And so by having an inscribed angle, and I'm going to kind of do this with a line tool, this angle always stays fixed, right? Oh, it's almost like if you guys ever seen Star Trek, it's almost like a Star Trek logo. So we've got like both of them here in one day. Star Wars and Star Trek. So this is 3 kilometers here anyway, and this is always going to be twice whatever that is. Okay, and so that's basically, if we cancel here, going to be pi over 2, right? Because the 2 and the 4 cancel as such, and you get pi over 2. And so that it means that we're going to use the fraction pi over 2 out of 2 pi. Or if you wanted to convert to degrees rather, pi over 2 is 90 degrees. So you could also do 90 out of 360 because they're equivalent. It's kind of like, I think I used the running example, like, right, 3K, 5K rather, is like 3.1 miles. So if you say, hey, I ran 3.1 miles, and I say, hey, I ran 5K, that's the exact same thing. So we're just talking about the same thing in 2 different ways, more or less. So if we do it like this, and you do however you want, again, it's got to be one of those 2 ways, you get pi over 2 times 1 over 2 pi, because you do, like, if you do the quote unquote keep change flip, and this becomes 1 over 4. So your fraction, your ratio is a quarter. And you can see 90 is also a quarter of 360. So it doesn't matter how you do it. But here's the thing. If this central angle is pi over 2 or 90 degrees, whatever, then this arc length represents a quarter of the circumference, because you've got that perfect proportionality when it comes to circles. So if this is the kilometers of that piece, then you want 3 times 4 equals 12 kilometers for the circumference. All right, so hopefully you're able to get this one. And so the main idea underpinning this is that we have these things called inscribed angles. You can choose this. I can choose that. We could choose this. It doesn't matter. No matter what point you choose as this vertex, this central point, you form what we call an inscribed angle. And the inscribed angle always has half the measurement of the central angle. Okay, and that's the one that's formed, as you see here, circled by when you have the vertex of the angle being the center of the circle. And that will never change, right? Because the center of the circle is always the center of the circle, right? That has to be stationary.